Hi there, my name is Matt Jones. I am a fourth year graduate student in math at Dartmouth College. Always been interested in math and science. I grew up in northern Minnesota, but both of my parents were actually scientists. My dad was a fish biologist and my mom was a chemist. And so all through my childhood, I was seeing science everywhere. Uh, I remember as a kid one day, we all got together as a family and built a small pinhole camera and watched Venus cross in front of the sun, which was very cool. Or we also had all sorts of little toys. This is a gyroscope. Gyroscopes are basically magic. Not really, it's science, but it seems like magic. So what happens is I'm going to get it spinning, and they seem to defy gravity. Pretty cool, huh? So this is an example of something that seems to make no sense. What it actually is it's science. This little disc in here is spinning around, and it makes it do all sorts of weird things, right? They use gyroscopes in space. They use them in the space station. They use them in all sorts of computers, things like that. A very cool little toy. A gyroscope is an excellent example of something that's very weird, but can be explained with math. And that's why I really like math. We often learn in school, and it seems like we're just doing things like solving for x. Math can seem very boring. It's just computation. It's just messing with numbers. But really what math is it's a bunch of tools. It's a bunch of tools to help us understand the world. And that's what I like. We use math for all sorts of things that you might not think that they have much to do with math at all. For instance, if you look at a map of the United States, you'll see that all the states are colored. And they're all colored so that they're different from their neighbors. Um, and uh, a natural question to ask is, how many colors does it actually take to color this map? Does it need all the colors that it has there? Could we do it with fewer? What about a different country? What about coloring all the countries in Europe, for example? Do we need the same number of colors? Do we need more? Do we need less? And that's actually an answer that math can answer. That's actually a question that math can answer. We also use math for things like sending secret messages. If you want to send messages to your friends and you don't want anybody to read them, well, math can help you do that. Or maybe you want to draft the perfect fantasy football team. Math will help you draft the best fantasy football team. Or maybe you want to talk to aliens. Pretty exciting. And that's something that math is useful for as well. I don't actually do any of those things. I do something a little bit different in my personal work. I study collective action problems. So what that means is that's when you have a whole bunch of people together and they need to decide what to do. Or you have a whole bunch of people together and you want to see how they interact. Those are the kind of problems that I study. So for example, let's say that you and your friends want to go get dinner on a Friday afternoon. Okay, but half of you want to go get pizza and half of you want to get Chinese food. Well, how do you decide where to go? If you're all in the same room, it's not too bad. You just take a vote. Have some of you raise your hands for pizza, some of you raise your hands for Chinese food, and that's the end of it. Things get a lot more complicated though if maybe you're not all together yet. Maybe you're all trying to talk on the phone, but you don't actually have each other's phone numbers. You only know some of your friends' phone numbers, which means that you can only talk to some people. That is a much more difficult problem, and that's the kind of problem that I tend to work on.